Alright, what is the absolute value of a complex number? Well, the first thing you need to know is absolute value. The definition of absolute value is a number's distance from zero on a number line. So, like the absolute value of -5, well, if you're on a number line, doesn't matter where you're at, -5, this distance to 0 is still just 5. So absolute value is really just distance. So when it asks for the absolute value of a complex number, well, complex numbers are written as a plus bi, where I is an imaginary part and a and b are real parts. So let's say I gave you 3 plus 4i. Okay, so we need to put that on two number lines. One number line that represents the real numbers, so this would be your real part, a, and one number line that represents your imaginary part, and so this is your bi part. So this is your, the y-axis now becomes your imaginary axis. The x-axis is your real number axis. So 3 plus 4i, now you can just graph it like an ordered pair. So that would be 3, 4 on this plane. So you'd go right 3, 1, 2, 3, up 4, 1, 2, 3, 4, and that is the point 3 plus 4i, and there's a vector that represents that particular point. So if we want the distance, the absolute value of 3 plus 4i, and that is written as 3 plus 4i with absolute value symbols around it, we just need to find the distance of that vector. And so you just set up a right triangle and do Pythagorean theorem, or the distance formula. So this is 3, this is 4, and so 3 squared plus 4 squared equals c squared, which this is c, because we're doing Pythagorean theorem, if you remember that, a squared plus b squared equals c squared. And so your problem then would be 9 plus 16 equals c squared, which is 25. And the square root of that then, to solve for c, is 5. And so the distance, or the absolute value, excuse me, so the absolute value of 3 plus 4i is equal to 5. So if you wanted to do, here's another example. Let's say you had the number 2 minus 2i, the complex number. So again, this is your, if you have a plus bi is any complex number, this is your real number part, this is your bi part. And so, you know, you're used to seeing this as the x-axis and this is the y-axis. So think of these as ordered pairs. So this one would be 2 minus 2. Or in this case, a and b would be your ordered pair. So if you graphed 2, negative 2 on this new imaginary plane, you would go right 2 and down 2, which would be right here. And so if we want to know the absolute value of that, so the absolute value of 2 minus 2i, so now we just need to do the distance formula or Pythagorean theorem to this right triangle here. So this is 2 and this is 2. So a squared plus b squared equals c squared. And so 2 squared plus 2 squared equals c squared. And you can, you know, I took out the negative 2. You know, I could put that back. I should put that back. So 2 squared plus negative 2 squared equals c squared. Well, when you do that, that's 4 plus 4 equals c squared. So 8 equals c squared. And I'll move down here so we have some more room. So then you'd square root both sides. And so c is equal to the square root of 8. Well, you could get your calculator out and figure that out. It's going to be like 2.8 something or something like that. But let's leave it as an actual number. So that'd be 2 and 4, 2 and 2. So my distance is 2 root 2, if you remember how to simplify those radicals. And And so that's the absolute value. So we know the absolute value of the complex number 2 minus 2I is equal to 2 root 2. Alright, so what if you just had the imaginary number 5I? Well, all complex numbers are written as a plus bi. So if you just had 5i alone, that's the same as saying 0 plus 5i. And so again, this is your a-axis, this is your bi axis. And so this is telling me that 0, 5 is the point we want to do. So 0, 5, 1, 2, 3, 4, 5 would be straight up 5 along the imaginary line. And so that would be a distance, this one's pretty easy, that would just be a distance of 5. So the absolute value of 5i is just 5, because that's the distance along the y-axis. And I hope this helps, and see you next time.